Leetcode problem. 2267, check if there is a valid parenthesis string path. The problem is really same as the Leetcode dungeon game. So we are giving a 2D grid, and inside the grid there are going to be open and closing parentheses. We want to find a root. So for example, in this root, let me make it right. So for example, in this root, the gray color, what it gonna like? It is a open, close, open, open, close, close. Yeah. So for such cases, we're gonna represent as A with parentheses. It is a some cases, or it can be AB. So AB is just open, close, open, close. It's gonna be something like that. Yeah. So we just need to check if this path is a valid parenthesis or not. Yeah. But we don't need to use a stack because this is a DP problem. For solving such problem, first of all, it is a grid problem, and secondly, we need to check the constraints. So mn is just 100, and there's only mn, and the grid is open and close parentheses. And now we can analyze a little bit about the time complexity first before we solving the problem. Otherwise, while you analyze the time complexity, it also helps us to solve it. So let's try to analyze a little bit. So mn just 100, but how can we solve it? So for the dynamic programming, normally we're gonna check the grid one by one, so from the top left to the bottom right corner, but I prefer to use a DFS. So for the DFS, I'm gonna start from the R and C. Definitely, I'm gonna starting from the top left corner, and I'm gonna reach the bottom right corner. So R and C, what is the time? M times n. So 100 times 100, it is 10 to the power of 4. Now we need to try to find another way. How can we record the state at each position? Basically, we need another two vectors. We need to record how many open parentheses and how many closed parentheses. So for example, if the open parentheses is always more than the closed parentheses, 3 and 2, it means it is always be true. Maybe next one gonna be a closing parentheses. It can be a true. But what is the closing parentheses is more than the open parentheses? For example, 2 and 1. Definitely, it's gonna be a true, false. So for example, from here, the closing parenthesis is 1, open is 0. So definitely, it's gonna be a false. So according to this way, we can check if it is a true or false. So this means we need another two states. It means the number of open parentheses and the number of closing parentheses. So let me make it open and close. So for the DFS, definitely we're gonna need 4 characters, 4 vectors. So for RC, definitely we need it. This is from the beginning, top left corner, and then we're gonna need the number of open parentheses and the number of closing parentheses. So basically we need 4 variables. And let's check the open and closing parentheses. So for R, it can be 100, and C is also 100. And what about open and close? It is 100 and 100. So so time together, it's gonna be 10 to the power of 8. But normally this gonna be time limit exceeded. But actually it is not 100 times 100, because the open parenthesis is always more than the closing parenthesis. If this open is always more than the closing parenthesis, let's analyze the time complexity. So because this is just 100 times 100, but if we just choose a path and how many of them, so if this is m and this is n, so basically it is m plus n minus 1, if I calculated it right. I'm not sure. And how many of them? 1, 2, 3, 5, 6, and 7. And how many rows and how many columns? It is 7. Basically we need to use m plus n steps to rotate from the top left to the bottom right. So row and column. So this is just row and column. Yeah. Now, yeah, because this one m plus n, what it can be for this m plus n? If this is 100 times 100, this m plus n can be 200. But what if this is 5,000 times 2? So m plus n may be 10 to the power of 4, but it's gonna still be a big value. Yeah. But for our tag, so for the open and closing processes, yeah, so yeah, if it is like this is 100 like 5,000 columns. Yeah, so if there are 5,000 columns, if we are going to check the open and closing processes, how we gonna check it? Yes, so so for this R and C, it's gonna be, yeah, normally it's gonna be 100 times 100. If it is 100 times 100, yeah, so if the open, yeah, normally it's gonna be 100 times 100 for the maximum. Yeah, but this O times C can also be, yeah, it can also be really long. I think it depends on the testing cases, otherwise it cannot pass. Yeah, so if it is like 2 times 5,000, this grid is like this. Yeah, let me just check the testing case. Oh no, it is not like that. Yeah, because m and n, we don't have that testing case. This is why we have to check the countries carefully. So m and n should always be more than and equal to 1, less than and equal to 100. Now we can analyze it easily. Yeah, because we don't have this kind of testing case, it's going to be easier for us to check. Normally, for the maximum, it's going to be 100 times 100. Yeah, if it is 100 open, 100 close processes, yeah, normally the open should always be more than the close. So if open is 100, so close can be from 1 to 99. Yeah, so this means the total number is 1 plus 2 plus 99. Yeah, so it's similar like 5 times 10 to the power of 7 for the total time complexity. So this is why we can pass, because here is just 5,000 and m times n is 10,000. So this is for the time complexity. Normally we can pass. Yeah. Now let's just start writing the code. I think we're gonna prepare a class for the DFS. Inside it's gonna be RC with open and close. Let me give a pass, and then we're gonna finish writing it. So we're gonna return. Yeah, we're gonna have a record of the result. It's gonna be DFS from 0, 0, and open also gonna be 0, and close also gonna be 0. Yeah, and we're gonna use a cast clear. So DFS, we're gonna use a cast clear. Yeah, because normally it consumes too much memory. We're gonna clear it and get the final result. Yeah, so like writing the DP grid problem, normally we're gonna have a first check of the boundary. So if this R more than or equal to R, or C more than or equal to capital C, or open, yeah, less than the close. If open less than close, definitely we're gonna return a false. Yeah, so from here we can prepare this R and C. So for R and C, it's going to be the length of the grid and the length of the grid 0. Yeah. Now up to here, it is okay. And then we're going to check the different cases. So, for example, we are starting just from 0. So this is open, and the number of open and close is 0. So from the beginning at this position, so we're going to check if it is an open or close at this position. So we need to check that. So we can check if this grid RC equal to open first. Yeah, so if it is equal to open, so we're gonna check two different cases, and it's gonna be R plus 1C with open plus 1 and close. Or, yeah, we just need to check either of them is okay, so we can return a true. DFS RC plus 1 still gonna be open plus 1 because it is open and close. So this is for the open processes. So if it is a closed processes, we're gonna use else to return another case. So it's gonna be close plus 1, and others gonna be the same. Yeah. So open should not plus 1, and close should plus 1. Now we can try to finish the return. So this is just the boundary case, and now what if we go to the bottom right corner? What are we gonna check? So we need to have a final check. So if R equal to R minus 1 and C equal to C minus 1. Yeah, so from here we can check, but we didn't count this cell yet. We have to check if this cell is open or closed, right? So we have to check if grid RC equal to an open processes. So if it is an open process, so we can return true if open plus 1 equal to close, else we're gonna return a false. Yeah. So if it is closed, we can return, yeah, let me just copy the code. So if it is closed, we can return true if open equal to close plus 1. Yeah, I think there are too many different cases. It always depends on what you would like to write. Or you can also put the open and close inside from here. Yeah, you can have two, maybe you're gonna have two different ways. Maybe you're gonna first check this grid with open plus 1 or close plus 1. Yeah, but I think that's gonna be difficult. You have to check that. Yeah, it's gonna be too much code. Maybe from here we're gonna keep 0 and 0, but for the last check we didn't count this yet. We have to class it. Yeah, or you can put it above the if check. It is still okay. It always depends on you how to write the code, but you should focus on the logic about it. Why we're gonna prepare this RC? Definitely we're gonna need it, and open close. That is why we gonna need it for the DP problem. Yeah, and the final value R times C times open times close is 10 to the power of 7 basically. So that is why we can pass. And now let me run it to check if it works. Yeah, I need to define the function, right? Yeah, it seems it works. Now let me submit it to check if it can pass. Yeah, as you can see, it passed, and the speed is also okay. Yeah, maybe we can try to delete this kind of case. Yeah, we can just have a check. What about the speed? What about the time and space? And you can see it didn't change so much, but you can check the space. It is 270. But what about if we use this case clear? Let's check the space. Yeah, and you can find that the space decreased immediately from 270 to 88, but the speed is just okay. So this is why sometimes we use case clear. Yeah, because if this memory is too large, we're gonna get memory excited. We have to use a DFS dot case clear to keep it working all the time. Yeah. I think that's for this problem. Thank you for watching. See you next time.